Have you ever been there, staring at a suitcase that's just too small, trying to decide what to take and what to leave behind? Well, that exact feeling is the heart of a classic computer science puzzle called the Knapsack Problem. Today, we're going to dig into this puzzle and explore a surprisingly simple strategy for solving it called the greedy approach. Let's see if it can help us pack for maximum value.
So, here's our game plan. First, we'll set the scene with our hiker's dilemma. Then, we'll get to know this greedy approach and test out a few strategies that seem smart, but you'll see. After that, we'll uncover the truly optimal solution. And finally, we'll talk about why a simple problem about a backpack actually matters a whole lot in the real world.
All right, I want you to imagine you're a hiker. You're out on the trail, and you stumble upon some amazing, valuable items just lying there. What's the catch? Well, your backpack has a very strict weight limit. This right here is a classic optimization problem. How do you cram the most value possible into your bag without it bursting at the seams?
Okay, let's get specific. Your knapsack can hold exactly 20 kilograms, not an ounce more. And your one and only goal? Maximize the total dollar value of what you carry out. Simple enough, right? So, what are our options?
Here are the goods. Item 1 is the big prize, right? A cool $25. But man, it's heavy at 18 kilos. Then there's item 2, worth $24 and weighing 15 kilos. And finally, item 3, worth $15 at a lighter 10 kilos. Now here's a really important rule for this particular problem. You're allowed to take fractions of items. Think of it like being able to scoop out some gold dust instead of having to take the whole heavy bar. This little rule is key. So with that in mind, how do we decide what to pack?
Well, this brings us to a really common problem-solving technique in computer science called the greedy approach. And honestly, it is exactly what it sounds like. You just make the best possible choice you can see at this very moment without worrying about what might happen down the road.
You know, the official term is that a greedy algorithm makes the locally optimal choice at each step. All that really means is it picks the best-looking option right in front of it, and then it does the same thing for the next choice, without ever planning more than one step ahead. It's the ultimate live-in-the-moment strategy.
And this is absolutely crucial to understand. Once a greedy algorithm makes a choice, that's it. It's locked in. There's no going back, no second guessing. This makes these algorithms super fast and efficient, but as we're about to see, that short-sightedness can sometimes lead you down completely the wrong path.
So let's put this greedy thinking to the test. We're going to try out a few different strategies that seem totally logical on the surface. Let's see how they actually perform when the rubber meets the road.
Our first two strategies are pretty much pure gut instinct. Strategy 1 is simple. Go for the big money. Grab the most profitable item first. Strategy 2 is all about efficiency. Travel light. Grab the lightest item first to leave room for more. Both sound pretty smart, don't they?
And here's where it gets interesting. If we go for pure profit first, we end up with a total of $28.20. Okay, not bad. But look at this. Prioritizing the lightest item first actually gets us more, bringing our total to $31. That's definitely better, but it still begs the question, can we do even better than that?
And it turns out the answer is yes. Neither of those simple strategies is optimal. To find the true maximum value, we need a smarter, greedy approach. We need to find the items that give us the most profit per kilogram, the most bang for our buck.
And this right here, this is the core insight. The best metric isn't just raw profit, and it isn't just low weight. It's the density of the value, the profit you get for every single kilogram. We need to find the most efficient way to use up our limited backpack space.
Let's see how this optimal strategy plays out. First, we calculate that profit-to-weight ratio for each item. As you can see, item 2 is the clear winner with a ratio of 1.6, so we pack all 15 kilograms of it. That leaves us with 5 kilograms of space left. The next best item is item 3, so we fill our remaining 5 kilos of space with half of that item.
And there it is. By focusing on the profit-to-weight ratio, we land at a grand total of $31.50. This is the true maximum value we can carry, more than either of our earlier, simpler strategies. Now, this might seem like a simple puzzle about a hiker's backpack, but the principles of greedy algorithms are incredibly powerful. They show up in all sorts of complex, real-world systems you use every single day. I mean, this what's the best choice right now way of thinking is everywhere. It's used to find the most efficient paths for data on the internet, to help plan power grids, and even to help machine learning algorithms find patterns in massive amounts of data. At its heart,
Making the best local choice is a powerful tool for solving huge optimization problems.
So, our greedy strategy worked perfectly, but only because we could take fractions of items. So let me leave you with this. What if you couldn't? What if it was all or nothing for each item? Suddenly, our clever, greedy approach fails, and the problem becomes drastically harder to solve. And that, well, that's a puzzle for another day.